Hello, Wellesley High School. Today we're going to talk about LeChatelier's principle. So when a system is at equilibrium, it means that the concentrations of all the compounds remains constant. The rate of the forward reaction exactly equals the rate of the reverse reaction. What LeChatelier's principle tells us is that if we disrupt that system in some way, if we add a stress, the system will react to counteract that stress to regain equilibrium. If we look at this system, we see nitrogen gas reacting with hydrogen gas, yielding ammonia gas and heat. One example of a stress on the system is to add excess of one of the compounds. In this case, I'm going to add extra N2. If I add extra N2, that means I'm going to have too much N2. So I want to react in such a way that uses up the nitrogen gas. If I shift the reaction to the right, the nitrogen gas will be used up, reestablishing. Another way to shift the equilibrium is to remove one of the products or reactants. In this case, I'm removing N2. That means I'm going to have too little N2, so I'll want to make more. If I go in the left direction, I'll be making N2 from NH3. That'll replenish my supply of N2 and reestablish equilibrium. A simple way to remember this is that if you add excess of one of the compounds, you're going to shift away from that compound to use it up. If you remove one of the compounds, you're going to shift towards that compound in order to make more of it, and that will help to reestablish equilibrium. If we look at the third stress, it says to increase the temperature. If we notice this reaction is exothermic, okay, heat is a product. If I increase the temperature, that means I'm going to have too much heat. So I want to shift away from the heat to use it up. So if I increase the temperature of this reaction, because it's exothermic, this reaction will shift to the left.